Okay, the masked professor is on the air once more. Greetings and salutations. Today we are going to go deeper into network node analysis, doing some practical problems and giving you a little bit more information. First, I wanted to talk to you about Pert Estimating. Okay, Pert is relies on, well, first of all, it stands for Program Evaluation Review Technique. All right, and with Pert, we look at, this is the, from figure 5.2, the range estimating technique that we talked about before, but I'm using it for my own evil purposes here. In Pert, there is a recognition that we're likely to have optimistic forecasts of time, pessimistic forecasts of time, and the most likely forecast of the time. So, what we do is we put all of those times down. Here's optimistic, most likely, and pessimistic. We are going to use a weighted average on those to determine what we think will be the most, will be a likely time that we should use for our project. All right, so how we do that is we have this formula where our PERT time is equal to the summation of our optimistic time plus 4 times our most likely time plus the pessimistic time and divide by 6. Okay, well, gosh, that seems like a pretty simple formula to me. All right, so I come down here and we're going to do our first work package, approval. The optimistic time is 1, the most likely time is 1, and our pessimistic time is 3. So therefore, I go equals, left parenthesis, optimistic plus 4 times my most likely time plus pessimistic time, right parenthesis, and divide that by 6, and I get 1 1/3 time periods as the most likely time to complete this project, or our PERT time. I shouldn't say most likely because we're already using that term. All right, so all I'm going to do is I'm going to go down and repeat that process. Equals, left parenthesis, optimistic time plus 4 times most likely time plus pessimistic time, right parenthesis, divide by 6. All right, so I can just keep doing that all the way down, and in fact, all I'm going to do at this point is to pull that down so that I have the times for all of the PERT times for all of my different aspects of the project. All right, and you can see that only one business card scanner hookup has turned out to be an even number. So one thing about PERT is it makes it more difficult when you do your network node analysis. Now, not that that should really make a big difference. If we're going to use this technique, we can do everything on Excel, and we can just use Excel to do our calculations right along. Okay, so that's it for the program evaluation review technique. We're not going to test you on this, so you need have no anxiety in that regard. However, you are going to need to be aware of this technique when you go out into the real world to manage projects. You may work for an organization such as the U.S. government that wants this kind of analysis. All right, so having done that, I am going to switch over. Now I've used that our same chart from 5.2 here for creating a network, right? And so I have created this and since they don't list any precedents of these activities, I've made up my own, right? And somebody else might look at this and say, no, this should go before this, and this should follow this, etc., etc. But for our evil purposes, that doesn't matter. All right, so let's look at the network. All right, so I've created this network over here, and I hesitate to make it smaller because it seems like it's going to be pretty hard to read as it is. So we start, of course, with our forward pass. So that means I'm going to start here with approval. What is the start time? The start time is always 0. All right, so our start time is 0, which means that our early finish time is going to be equal to our early start time plus our duration, right? Now you'll notice that I've gone ahead and coded that in to the Excel diagram. That is because when I create a network node analysis for a project, I've got to be able to quickly change if we end up having a work package that comes in early or one that we have to give more time, etc. And it's better if it can ripple through the system. All right, all the durations that I'm using here are the most likely durations as listed in the table. All right, so now all of these work packages that immediately follow designing the packaging, identifying our customers, designing the bottle, having a production test, are going to be equal to our early finish time, right? So I'm just going to hard code that in for all of those. Well, I say hard code, actually I'm just coding it in. All right, of course, for all of these, our early finish time is equal to our early start time plus our duration. Okay, so I'm going to go ahead and put the code in for those. Equals early start plus duration equals early start plus duration equals early start, let me get it up higher so you can see, plus duration. All right. Now we have a bit of a conundrum. For example, branching out of our 104 is a burst activity. And as a burst activity, the early finish time is the time that immediately goes into the early start time for 106, getting a space at the trade show, and our early start time for, oops, that was the wrong one, and our early start for designing our brochure. When we look at 109 though, we have a very different situation. We have a situation where designing the packaging and designing the bottle both have to be done before we can put an advertisement in the trade journal. Okay, now in this case, it happens that they're both the same. But what if one of them changes? So in that case, we're going to say equal max, right? So it'll choose the maximum number between finishing design of the packaging and finishing the design of the bottle. Okay, well, either way it's going to be 8 right now, but what if the guys designing the bottle come to us and they say, look, can we have 2 more days or 2 more time periods, whatever it is? Then it's going to automatically update when we change the time to design the bottle. All right, and then in producing wine to inventory, we also have a merge activity where we need to say equals max of our design of packaging, comma, our design of the bottle, comma, and our production test. All right, so you can see here that it is chosen 15, obviously the largest number, since the 2 others are each 8 time periods. All right, so having done all of that, we come over here and we continue our forward pass, and we say this is equal to our early start plus our duration. Come down here, this is equal to our early start plus our duration. Under the, for the trade journal, again, it's equal to our early start plus our duration. And for building wine to inventory, it's equal to early start plus duration. All right, so super exciting. All right, so we come over here. Now here is the activity of building our kiosk. And it only has one predecessor, right? So we're going to say that that is just equal to our early finish for getting a space at the trade show. Right? Now, if we decide there's a different precedence that we're going to use, we would have to change that. But for right now, no worries. All right, so having said that, we come over here. Our early finish time is going to be our early start plus our precedent. All right, now we come down here and our final bit is the rehearsal for the trade show. Okay, that's our end activity, and it's a merge activity. Once again, we're going to go equals max left parenthesis of our early finish for building the kiosk, comma, our early finish for making the brochure, comma, our early finish for getting the trade journal, comma, and building wine to inventory, our early finish of that. All right, right parenthesis. All right, so that gives us 36, not surprisingly, the largest early finish time. And now we just go to equals our early start time of 36 plus our duration. Okay, so that was the forward pass, right? Figuring out what is the time needed to totally complete this project is 38 time periods, right? I assume 38 days, but it could be 38 weeks or 38 months, although with some of these duration times, I hope not. All right, now we want to do the backward pass. Okay, so we come here for the backward pass. Our late finish time is going to be equal to our early finish time for our rehearsal. Our late finish time is going to be equal to our late finish time minus our duration. Okay? All right, so there we go. Now, that 36, that late start time is going to propagate backward to all of the activities that merge together for the rehearsal. So it's going to be equal to 36 here. It's going to be equal to our 36 here, equal to our 36 here, and equal to our 36 here. Right? Once again, I have gone ahead and coded this in. All right, so here, what is our late start time? Our late start time is going to be equal to our late finish time minus our duration. And that number is going to transfer over to our late finish time for getting a space. So equals our our late start time for building the kiosk. All right, well, of course, we then say, all right, what are the late start times for all of these? Well, this one is equal to our late finish time minus our duration. This is equal to our late finish time minus our duration, right? Obviously, it's all going to go the same way up and down the line. Equals our late start time minus our duration. And equals our late start time minus our duration. All right, so that's pretty easy. All right, so now we want to look at what happens with our merge activities, right? When we look at, well, for example, here's a burst activity, identify customers. And it has two different early start times associated with the two activities that come out of it. There's 22 and 29. So we say we want the smaller of the two. So we say equals min, click on the late start for finding space, comma, click on the late start for getting starting the brochures, right parenthesis, right? And so we look at all of our activities through that lens. Here we want the earliest time that we have a late start. So equals min, left parenthesis, putting it in the trade journals doing the trade journal thing, and comma, and building wine to inventory. All right, come down here, designing the bottle equals the minimum of the late start for the trade journal and the late start for inventory, right parenthesis. And here we only have one choice, so it's just equal to our late finish is equal to the late start for building wine to inventory. All right, once again, we're just going to go through the same exercise we have before to calculate our late start. Equals our late finish minus our duration. Here for identifying customers, it's going to be equal to our late finish minus our duration. Here, for designing the bottle, it's going to be equal to our late finish minus our duration. And for the production test, equals our late finish minus our duration. Okay, so now we have a variety of choices here for late start times, and we're going to bring the smallest one back to our approval process. So equals MIN for minimum of the late start for production, comma, late start for designing the bottle, comma, late start for identifying customers, comma, and late start for designing the packaging. Right? We put a right parenthesis, and once again, our late start has to be equal to our late finish minus our duration. All right, so you'll notice our early start and our late start are the same here. Well, the number that goes in here is the amount of slack time. So if we say equals 0 minus 0, our early finish minus our late finish, it's 0. Except I did it backwards. It should be equal to late finish minus early finish. Oh, silly me. Of course, it's still 0, but that is going to make a difference in our subsequent calculations. All right, so let's go up here to designing packaging. Here, our slack is calculated as equal to our late start minus our early start. Okay, so there we have 16 slack time periods. We come down to identify customers equals late start minus early start, and that's 0. Okay, that's going to be important in a minute. All right, we come down to designing the bottle equals our late start minus our early start. And you can see that's 16 time periods. And production test equals late start minus early start. Okay, so once again, we have some slack in all of these except identifying customers. So identifying customers looks like it's kind of important. All right, now we come up here to getting a space at the trade fair. We say that is equal to our late start minus our early start. Okay, and that is 0. We come down, we do the same thing for designing our brochure. Equals late start minus early start. For our trade journal, again, equals our late start minus our early start. And for inventory, once again, equals our late start minus our early start. All right, so you can see how this has gone. We go over to build the kiosk, and we say equals our late start minus our early start, right? Once again, that's 0. And then we figure out our slack for the rehearsal equals late start minus early start. Okay, so our beginning and ending modules should always have 0 slack. And we follow what is the line that has 0 slack to identify the critical path. Okay, so that means that approval is on the critical path. Our identifying customers is on the critical path. Identifying a space at the trade fair is on the critical path. Building our kiosk is on the critical path, and our rehearsal is on the critical path. And I'm feeling like I'm not making those pop out enough, so I'm going to go ahead and highlight those in yellow so that we can see what is the critical path. All right, so now if we could do this in kind of a fire and forget fashion, we wouldn't have to worry about coding in. We could just put the numbers in and call it a day. But what if we have some problems along the way? Oh, let me make it a little smaller so that everything's in at once. Oh, that didn't work out very well. Right? What if there's a delay in identifying space? Right? Instead of 10 days, it's going to be 14. Well, that suddenly It doesn't change the critical path in this case, but it does mean that now our early finish and our late finish are both at 42 days, or 42 time periods instead of 38. Right? Or what if a different part changes? Now, for example, I put building the kiosk out here. We could really have put building the kiosk somewhere else, because when you're talking about a trade fair, it's not that they tell you, oh, we've got this little triangular space over here that we could put you in. No, they have regularly sized booth spaces to use that are all going to be regularly sized. So the usual in the industry is a 10 by 10 space, right? But then some people will rent two booths next to each other, so they have a 10 by 20 space, or they'll rent 4 booths that are kind of back to back, so they have a 20 by 20. There's all kinds of different ways and configurations. We're probably going to decide how big a booth we want before we identify the actual space we go into. All right, well, enough about the wide world of doing trade fairs and conventions. All right, so here is, let me make this larger. Here is the automated warehouse order picking system. This is the precedence and the times and everything for that. So, you know what? Let's just go ahead and jump to a problem that you haven't seen. And I'll crack open the book here. Now, you've been assigned problems all right. You've been assigned problems 6, 10, and 13. All right, so let's go here, rename this as problem 5, 6-5, I should say. Okay, problem 6-5. All right, I'll bet you guys cannot read this at all. So let's go ahead and make this a lot bigger. All right. In 6-5, we have a chart where we have the identity, the description, and we have the predecessor. Is that how you spell predecessor? Oh. Okay, I've got my C and my D backwards. All right. So our identity of our first activity is A, right? Always the lowest identity. When we're building a network node analysis for a real world situation, we would do something like, we would have A, or we might say 100, and the next one would be 105. All right, description is order review. The predecessor is none. A is our first activity. Oops. All right, obviously our next one is B. And B is order standard parts. All right, its predecessor is A, as you would suspect. C is produce standard parts. All right, so this assumes that this is in a factory, and that that we are making the parts for certain products. Okay, its predecessor is also A. D, design custom parts, has the predecessor of A as well. E, software development, has the predecessor of A. F is manufacture custom parts. And I'm going to abbreviate that because it is ridiculously long. So I'm going to put that as MFG, custom parts. Its predecessors are both C and D. G is assemble, and that requires both B and F be completed. And H is test, which requires E and G to be completed. All right, so we have these 8 different activities that have to be completed for this to work. Now, what am I going to do? Right, I could go ahead and make a giant size activity activity node like this, you know what, it doesn't have the neatness that I want. So what I'm going to do is I'm going to come through here and I am going to move this down so that my squares are kind of square. Okay, and you can see how nicely that works. All right, and the other thing I'm going to do is I'm going to merge these two because that is where the description is. All right, so I'm going to copy this and I'll put that right here. All right, so right here is the ID. All right, so I'm going to say equals A. Right? Now, here I'm going to say equals my order review, but I'm going to go ahead and left justify that. And you'll notice it does not fit neatly into here. So I'm just going to decrease the size. Yeah, that's the ticket. So we can see enough of it. All right. I'm going to take this. I'm going to say, okay, I want to copy this again. I'll copy it right down here. No, I'm going to copy it here instead because I have to come up with 4 activities for which A is the predecessor. All right, well, you'll notice it's a little irregular and sloppy. Right, I'll go ahead and copy another one here so I've got that ready to go. Right, and I could go ahead and say, you know what, I'm going to need 3 more. Why not just go ahead and do those? So I'm going to take this and I'm going to come down and I highlight all of them and then I just go ahead and move them. Right, so that I've got it split evenly here. All right, now we know we want to keep them in order. So that means that we put B here, or I could go ahead and say equals my B equals my C equals my D and equals my E. Right, and right, so for B, I just go ahead and say, you know what, equals my order standard parts, except I want it to be left justified and a lot smaller. Here, I'm going to say equals produce standard parts. Oh, forgot the equals apparently. Equals produce standard parts. Again, going ahead and reducing the size. Equals what is D? Design custom parts, and left justify equals software development. All right, so again, I'm just going to go ahead and make these smaller so that they're more legible. Okay, there you go. So for F, it has to be, it's related to being able to have C and D okay, so I'm going to say this is equal to F and equal to B9. Oops. Equal to manufactured custom parts, all right. Right, and go through all the little steps. Now you may be saying to yourself, oh my God, this seems like an awful lot of work and excitement. But again, once you set everything up, it makes it a lot easier if you want to make changes down the line. All right, so here, this is going to be equals G and equal B9, which is a symbol. And then our last is our H, which is our test, has to be accessible to E and G. All right, so equals H equals B10 for our test. All right, so all I'm going to do then is I'm going to come here to Insert, go to Shapes, Arrows. All right, we know that we've got to have an arrow that goes from A to B, and I am not a huge fan of the blue that they give you as the automatic default, so I'm going to change that to black. Once I do that, you'll notice I have a whole format thing where I can click on this, start in the same place, go to C, Shape Outline Automatic, click on the arrow, go from here, from A to D, Shape Outline Black again, click on arrow, go from A to E, and there we go. All right, now we look at further down, make the custom parts, manufacture the custom parts, has C and D as the predecessors, right? So once again, I click on arrow at C, and go to F, and I click on the arrow, go from D to F, Once again, change it to black. A symbol goes from B and F. All right, so I can see I've made a mistake here where I need to go ahead and move G back a bit. In fact, even a bit more than that. And sometimes Excel complains about these things. And sometimes it doesn't. Why? There you have me. It's a mystery. Right, now I'm going to have to move test as well. Right, but this is kind of how you do it. As you're putting together a diagram, you're going to end up kind of feeling your way to an extent. All right, so C and D go into F. For G, B, and F go into it. So, go back to Insert Shapes, and I'm tempted to use my little right-handed all right, but I need to move this over. Go ahead and do the shape outline. All right, so that's how I ended up having to do that. All right, and F can be just a straight arrow. Right, and then test, we have to have E and G, right? So those can both be straight arrows. All right, so let me reduce the size slightly. All right, so you can see now we have put together our network and it makes sense. Everything has a predecessor except A, which is the first activity, and everything has a successor except H, which is testing the system that we've built. And there you go. We have made a network node diagram. Now, what is the problem with this? We can't do our forward pass, backward pass situation from this because we have no times. I mean, I could just put in a bunch of times, but oh bloody hell, let's go on to a different problem. In fact, actually, if we go to if we go to problem 6, 7, it gives us the same problem, except it does give us times. So I say, damn it, I'm stealing those times. All right, so order review, they're saying is the time is 2. Order standard parts is 3. Produce standard parts, they're saying is 10. Design custom parts is 13. Software development is 18. Manufacture custom hardware is 15. Assemble is 10. And test is 5. All right. Well, you know what? It's starting to look a little raggedy, so I'm going to go ahead and put all of these, do center, and then I'm going to go back and do left justification just for descriptions. Obviously, this is a bit of frippery, right? Nothing is actually made better by doing this, except that my OCD is assuaged. And assuaging OCD, very important. All right, so what is our early start time for A? Our early start for our first activity is always 0. Our early finish is always equal to our early start plus our duration. All right, that propagates through all the early start times. The early finish time of our first activity is the early start time for each subsequent activity. All right, so on our forward pass, I go to activity B. My early finish time is equal to early start plus the duration. For activity C, it is equal to the early start time plus duration. Equals my early start time plus the duration. And once again, equals the early start time plus duration. All right, so now we've been able to do the forward pass as far as our activity E. All right, because F is a merge activity, we're going to say it equals the maximum value of early finish for produced standard parts and early finish for design custom parts. Close parenthesis, Bob's your uncle. Therefore, our manufacture custom parts time becomes our early start time plus our duration. For G, our early start time is the maximum value of our early finish for B, comma, and our early finish for F. Right, parenthesis. All right, so therefore our early finish time for G equals early start plus early finish. Excuse me, plus duration. Blah. What am I thinking here? All right, therefore, we get to H, which is test. That means is the maximum number between the early finish for G and the early start for E. Close parenthesis. And therefore, our early finish time for H is equal to our early start time plus our early finish time. All right. So, now we do our backward pass. And we know that our late finish time for H is the same as our early finish time. And that our late start time is equal to our late finish time minus our duration. Our because this is a merge activity, our late start time becomes the late finish time for all the activities that it depends on. So for assemble and for software development. All right, so for G, our late start time is equal to our late finish time minus our duration. And for E, our late start time is equal to our late finish time minus our duration. For both B and F, our late finish time is going to be equal to our late start time for G, because they are the activities that must be completed first. Our late start time is going to be equal to our late finish time minus our duration. And for B, it's going to be equal to our late finish time minus our duration. Since our C and D are both feeding into the merge activity of F, their late finish time in both cases is going to be equal to the late start time for F. All right, therefore, when we go and we calculate the late start time, it's going to be equal to the late finish time minus the duration for both of them, equals R minus K. All right. Now, because A is a burst activity, it is going to, our late finish time is going to be equal to the minimum value of the late start times of all the subsequent activities. And of course, our late start time is equal to our late finish time minus our duration, once again. All right, one more thing that we have to calculate is our slack time. So that's equal to late start time minus early start time. And we go through, all right, late start time minus early start time equals late start time minus early start time equals late start time minus early start time equals late start time minus early start time equals, bloody hell, late start time minus early start time equals late start time minus early start time, and finally equals late start time minus early start time. All right, having done that, that means that we now can identify the critical path by any activity that has zero slack. Okay, and remember that it could be that you have multiple parallel paths that have zero slack. For example, if C here were 13, it would suddenly have zero slack, right? But we know that it's 10, so we'll leave it as it is. Okay. I would like to do another problem. We don't have quite enough time. Okay, but hopefully this video has let you know and given you some experience. I hope you're following along and creating these network node diagrams with me. given you enough experience to be able to create not only the network node diagrams necessary for the homework, but also for your class project. This file is going to be here on the instructor's computer where you can access it, assuming you're one of the students that is coming to school. We have one student that may be SOL in this regard since he is, has been attending remotely. So, thank you very much. This is the Masked Professor signing off, and enjoy your day, enjoy your weekend. Don't forget, this is Patriot Day, 9/11. Please remember those who died in the attack on September 11th, 2001. Thank you very much.